Um, all right. This is the main classification algorithm. That is where the model it is from. I think, as we discussed last time, that is what you are going to use to make presentation to your supervisor. So what we do, the first thing is that we import libraries. Libraries, they are modules. They are like attribute ko kuma they are like additives that we normally use in Python programming language that will enable us to carry a particular functions. So these are libraries that will enable us to do this particular model. So I think the here I classify into four. We have the core libraries that we needed, and we have the helper that is pre-processing, and we have the machine learning models, algorithms, and we have the performance and metrics evaluation libraries. So for the for the core libraries, we have pandas, and numpy is for numerical, working with data matrix and data frames. And then we have the scikit-learn that is the main code library that we use for machine learning activities. And we have the matplotlib, that is when we want to plot graphs. And then we have the cbon is also for data presentation. And then the nltk, which is for the natural language toolkit. So we have the helper functions, which for pre-processing. So we have this train test split. Train test split, what it helps us does is that it helps us to split the data into two. So we are going to have a train and data set and a test data set. And we have this tfidf vectorizer and the count vectorizer. So normally when you are working with a data that is in text, and you want to train that data, you need to break that data into you need to bring that textual data into what that word. And then for example, each sentence you need to have they are in form of sentence, but so that sentence you have to break it into what. You assign values to it, and after assigning values, that what will help you, the values or the IDs that you assign per each word. That what will help you at the end of the day. The algorithm will make some computation, and the training will actually take place. And when you are trying to test, it follows the same process. So we are using two vectorizer here. We are using this tfidf vectorizer, and we are also using count vectorizer. So, and then for the machine learning models, we're using multinomial naive Bayes, and we're using logistic regression. And then the performance here, we're using confusion matrix, accuracy score, precision, and recall score. In fact, this classification report will even give us most of those things that we needed. So the second thing we did here, we import the data set. We have our data set that we earlier generated from that R, so this is it. We have a sentiment analysis output. That is after we've done our sentiment analysis, the data that we've gathered. And you can see this is a description of the data. We have the line number, which is the ID, and then we have the sentiment score. So which is here you can see we have 233 minus 1 minus 2 minus 2, and then these are the actually Twitter comment or Twitter post or whatever from the Twitter data. So since we as we computed the sentiment analysis, we have various schools. You can see we have even up to +7, we have -1, we have -10. We have a lot and a lot of within the 400, within the 4,000, is it 41,000, within the 41,000, 4,199 data sets that we have. This is actually, oh, okay, yeah. Oh, no, sorry, from the 2,948 data set that we have, this is actually what we we have various outputs like sentiment output. So since we are doing classification algorithm, we only need two values, which is 0 and 1. So for all negative sentiment that are minus, we have to declare it as 0. And for all the positive sentiment that are plus, we have to declare it as as 1. That is what we need to do. So now we need to transform our data, and what we do here is that this data log will actually enable us to access a particular column. So we're accessing sentiment column because it's under sentiment column that we have this scores, and we need to convert it into 1 and 0. So what we did, we say any sentiment that is below 0, that is less than 0, it should be equal to 0, and any sentiment that is greater than 0 should be equal to 1. So, and we loop into the data. We use range loop into the data, and then convert everything into 1 and 0. So here is the output now. If you see, you can see where we have 233, it has turned to 111, and where we have -1 and -2, you can see that it has turned to 0 0. And here we have 1, it is 1. We have -2 0, -1 0, 7 1, and then -1 0. So that is exactly what we need. Anywhere a number is negative, it is considered as a negative sentiment, and that it has been declared to 0. And anywhere it is a positive number, it is a positive sentiment, and it has been declared to 1. So remember, under helper functions, we have imported test, trend test split, and here we are using that function to divide our data set into 2. So we divide it into 2, and you can see we have point 2. This point 2 means like 20% of the data is going to be used as a test data, while the remaining 80% is going to be used it is going to be used as a training data set. So, and then here we're trying to preview the test data set and the training data set. So we've used the matplotlib here to actually compute this, and then here we display when we divide the data set into 80% and 20%. So we have the training data set of about 2359, while the testing data set is 590. And here, this is the display. This is the display. So this is the sentiment count for this is for the training data set, and this is a sentiment count for the testing data set. So then remember, we also import vectorizer that will help us to actually analyze the textual data that we have. So we first of all work with the count vectorizer. So here we imported our vectorizer as cvec, that is count vectorizer as cvec. We declare a variable cvec, and we import our count vectorizer here. So here we use our cvec, and we transform our data trend df. If you look at here, you can see when we split the data, we have trend df, test df. So this trend df, that is what we're using here actually, trend df. And then we also import our tfidf vectorizer as tvec, and which we also fit the trend df of the tweet text. And then here it has been vectorized, the vectorization has been completed. And then uh, uh and then okay, I think uh this did I repeat this test? Okay. And also transform the test. Here I transform the here we transform the trend data set, while in here we transform the test data set. So, and now we want to compute a little algorithm that will help us to understand the performance evaluation, that is in terms of the confusion matrix, the classification report, and what have you. So here we also use the matplotlib and the seaborn to actually create a heat map, and also to create a heat map and a graph, like a confusion matrix graph, or a confusion matrix heat map. So that is what we do here. So we've defined that, and then here we import our algorithm, our machine learning algorithm, that is the naive Bayes, that is multinomial naive Bayes. So and then here we declare it as MNB TF-IDF, that is multinomial Bayes for TF-IDF factorization. So now we computed that, and then we do the training, and after the training we now use the test. We now use the test data set, and this is what we have. So we have the did I calculate the prediction score, the general prediction score? Okay, yeah. So the general accuracy score is 0.79, which is 79.83% accuracy score. And from there, our precision is 77%, while our recall is 87%. That is for the prediction of a negative sentiment. And for the prediction of positive sentiment here, our precision is 84% and our recall is 72%. So what is the difference between the precision and the recall? The precision shine the ability to predict, to predict okay, for the ability, like to make the prediction. How will I put it? Okay, let me use something to make an example. For example, you develop a robot and you train the robot. So you ask the robot to go into supermarket to pick up a fruit, banana. So if the robot went to the supermarket and to pick banana fruit, 3 pieces of banana fruit. So if the robot was able to get into the supermarket and was able to pick up a fruit, and it picks banana, maybe it can pick another thing again. It can pick maybe banana, orange, and what have you. So that is precision. Precision is for it to be able to pick what it was asked it to pick. That is banana. So it has picked banana. You understand? So then the recall. The recall here is that when the robot went, if the recall is good, it's expected to pick only banana, not any other thing. So so precision is the ability to go and to predict what should be predicted, while the recall is the ability to predict exactly what is expected to predict. So in the precision, it can predict the needed thing and other things, but recall, it will predict what, or just what is needed, just that particular thing that is been needed. So that is it. So here we have the matrix, and then you can see that you can see that like everything goes well here. So and then this is the multinomial using count vectorization. This is the above, the one I've just explained is multinomial using TF-IDF, while this one is also multinomial but using count vectorizer. And in that, we have the accuracy score of 80.17, and you can see we have the precision of on the negative prediction, we have the precision of 84% and the recall of 76%, while in the positive sentiment we have the precision of 77%, while the recall of 84%. And then here we have the logistic regression. In the logistic regression, we also have logistic regression for TF-IDF vectorization, and in there the algorithm perform little better, where we have 83.22%, and you can see we have a precision of 79% in the negative sentiment and the recall of 93%, while in the positive sentiment we have a precision of 90% and recall of 70%. And then the last but not the least, which is logistic regression using count vectorization, that is where it performs best. And we have 86.44%, and we have the precision of 83%, recall of 93%, percent. That is for the negative sentiment. And for the positive sentiment, we have the precision of 91% and the recall of 80%. So this is for this. So if you want me to explain the other, then I will do explain them. Yeah.